Hey everyone. So this week we are looking at the combustion, and normally we'd have molecule kits. We would take actual kits and pull them apart and put them together and see what's going on when I burn something. So we looked at the burning of methane, which is natural gas, and when you have a burning process, it's a reaction. We have bonds. We are breaking them, and we need to use something to show that to see what's happening with the actual molecule. So what I need you to do today is to build a molecule kit. Um, I just took some. So we need atoms. Now you can use. I used aluminum foil. I just made little balls, but you need to label them somehow. And so we have one that is a carbon, so I just put a little C on there. We have a couple of them. We need four of them that are hydrogen. So this is hydrogen. It's a little. I just put a little piece of tape on it and wrote H. You can do the same or just write H, or just use paper, a different color paper. If you have construction paper, little balls of paper work great. So you need four of those, and you also need four oxygens because the when you react the methane in the air and you're burning it, it's oxygen. So we need four of these. I just have also aluminum balls, but there are oxygen, and I just put a little O on it. So four oxygens, okay? And you also need some toothpicks or some kind of tape or something to stick them together. I think toothpicks work great. So you need oxygens to stick together like this. So we need, so an oxygen molecule is O2. So we need two oxygen molecules. And then we need methane, which is, drop the hydrogen here. So methane has carbon in the middle, and then you have four hydrogens sticking out of it. So one, two hydrogens. It doesn't really matter where you stick them. I'm going to stick them how they are normally set up. So I guess this is a topic for another discussion. But when methane is stuck together, it looks like this. I'm dropping hydrogen everywhere. Okay, there we go. So right here, like this, that is methane. Okay, so methane, it has one carbon in the middle and four hydrogens, and now we can react them together. So as we're thinking about what's going on when we burn something, what's happening when you start taking this molecule and breaking it apart? We're going to break the bonds. We're going to look at bond energies today. So make sure you get a molecule kit made, take a picture of it, and put it into your document so I can see that you made a molecule kit. Keep it in a little bag. We will use this for the next couple lessons, okay? So make this, don't lose it. Okay, so in the last video we were looking at the bond lengths, and we're going to look and see what's going on with the different bonds as we burn something like methane. So methane is natural gas, and as we burn it, what's going on with the bonds and how much energy is that taking? So we're going to start with the CH bond, and we'll do one together, and I'll have you do the other one yourself, and just kind of looking at what's going on as we're taking this molecule and we're busting it apart. Okay, so I'm going to take one of the atoms and make it carbon, and the other one's going to be hydrogen. And as we do this, we are going to be moving them closer together. Remember, as they get close together, there's a point at which they're balanced, so that the repulsive and attractive forces match up. And so we can see that this reaches this balance point down in the bottom part of this graph. And so as I look and see, well, this is going to reach over right around negative 4.0 on the potential energy graph, and that's in joules. And so these are just like random rough measurements. We're just going to write them down in our table. And so we're going to write 4.0 joules. And now the question becomes, well, if I have this set of atoms and they're bonded together, so remember this is my molecule here, this is my methane molecule. As I'm taking this and I'm pulling them apart, I'm breaking them apart, remember what is going on? Am I putting energy in? So look at where it is on the graph. It's on the bottom of the graph. What's happening to the energy as I start splitting these atoms apart? How much energy am I putting in for that one bond? And then when I have 4 of them, so remember there's 4 of them, what's going to be the total amount of energy as I break that apart? Okay, so think about what's going on as I'm breaking these apart. How much energy am I putting in? And then we're going to do the same thing. So I want you to do the same thing. We have the oxygen here. So if I redo this and I make both oxygen, okay, let me erase this. What's going on when I have these 2 oxygen atoms? Where does that meet up? So find it on the graph, okay? If you can't get this to work, I'm just going to do it right here, and you can measure it right off of this picture. So I have this, whoops, something happened here. Okay, we're going to try that again because the video froze up. The 2 oxygen atoms, we're going to move them to the bond length and take a look at the energy. So think about, I have oxygen together, and as I break it apart, so I'm going to move them together, and we see that it has this nice well down here, the perfect balance, attractive and repulsive forces. And then as I look at how much energy that is, what is that around? And so we get that mark here, it's right around, it's a little less than 2, but greater than 1, so maybe like, 1.5 joules down there. So as I take this set of atoms, the oxygen, and I start pulling them apart, what's going on with energy? Do I put in energy to break them apart, or is energy coming out somehow? So do I got to put in energy to break them apart, or is energy being released? So that's kind of the big question here. What's going on with this set of atoms?